Problem 24. If circular arcs AC and BC have centers at B and A respectively, then there exists a circle tangent to both AC and BC. Problem 24. If circular arcs AC and BC have centers at B and A respectively, then there exists a circle tangent to both arc AC and arc BC, and to segment AB. If the length of arc BC is 12, then the circumference of the circle is what? First, we can kind of connect these points, and we get an equilateral triangle because we know that AC equals AB. They're both radii of the circle at A. And AB equals CB. They're both radii of the circle at B. So therefore, AB equals AC equals CB, and we have an equilateral triangle. Next, we're told that the length of arc BC is 12. And since this is equilateral, this is 60 degrees. So arc BC is 1/6 of the circumference of the circle at A. So we can write 6 times 12 equals 2 pi r, which gives us AB equals 36 over pi. I'm going to go ahead and construct a right triangle here. What we want is this r, and we can write using the Pythagorean theorem and knowing that this segment is 18 over pi. We can use the Pythagorean theorem to find that this segment here is equal to the square root of 18 over pi squared plus r squared. And if we add r to that, which is basically this amount, if we add r, we get this length right here, which is equal to AB, because both of those segments are radii of the circle centered at A. So this is equal to AB. We know that AB is 36 over pi. So now we just have an equation that we can solve for r, which should be pretty straightforward. So if we move r to the other side and square, we get 18 squared over pi squared plus r squared equals 36 pi minus r squared, which equals 36 squared over pi squared minus 72r over pi plus r squared. We can cancel out the r squared, and we get r equals 36 squared minus 18 squared over pi squared times pi over 72, which equals, using the difference of squares formula, 54 times 18 over pi times 1 over 72, which equals 27 over 2 pi. The question asks us for the circumference of the circle in the very center there, which equals 2 pi r, or 2 pi times 27 over 2 pi, which equals 27. So the answer is D. A possible mistake, and one that I made when I first did this problem, was assuming that the segment from this point to this point was the same as the segment from this point to this point, which will give you a wrong answer. So that's just something to be aware of. That's the end of the video. Thanks for watching. If you found this helpful, please leave a like, and if you have any questions or feedback, please let me know in my comments, and I will get back to you.